Good evening, guys. On behalf of School of AI Trivandrum, I welcome you to the day 7 of Python study group. Before we get started, let us look at what we have learned in our previous class. We have looked at function. Function is actually a part of a code that can be invoked from another part of a code. We have also looked at how to define a function, how to call a function. Then we went ahead and looked at star arguments and star star keyword arguments. We have also looked at lambda, map, and filter functions. And we ended previous class with looking at different scopes within Python. So this is what we have learned in our previous class. To get this presentation, you can go to the following link, tiny.cc/soai-python-week4-1. This is the link to the current presentation. You can start asking doubt in the chat panel. Okay. Today we will be looking at object-oriented programming. We will look how to create a class, how to create objects, inheritance and polymorphism, and special methods. So let's start. I request all of you to open Colab Notebook and start coding along with me. Okay. One thing that I have missed out in the previous class is we have not looked at the docstring of a function. We will start with that. We will look at what is a docstring of a function. Or okay, I have defined a function that will return the area of a circle. So when you pass area radius as 1, you will get the return area value as 3.14. So there are already built-in functions like for a list, let's say for a list 1, 2, 3, 4. And if you want to see one of the method within that function, see, this is a function within that list. So you can actually type help followed by l dot sort. Okay. So what you are seeing here is actually the docstring for that function or docstring for that method. So can we provide a docstring for our own functions or the user defined function? You can also do that. In here, what if we try to print the help of area of circle? See, currently we don't see anything or any help returned as a string. That is where the use of docstrings comes into place. You can actually define like a documentation saying what this function does. This function is used to calculate area of a circle. Okay. Now we have added a docstring. All you need to do is inside 3 double quotes, write whatever you want. And when you run this cell, and now when you try and print out the help, you can actually see that this function is used to calculate the area of a circle. And what you are seeing here is called a doc string. That is a documentation string, you can say. So this is what I have left off, or I have missed in the previous class. Okay. Now let us look at today's content, that is object-oriented programming. Okay. So what is object-oriented programming? Object-oriented programming is a means of structuring programs so that the properties and behaviors are bundled into a single individual object. You can see that when you created a list, it actually comes with set of inbuilt functions that is bundled together into the type list. L dot and followed by tab, you can see all the inbuilt functions that is being bundled together with this list. This is because of the property called object-oriented programming. Now we can create our own classes, and class is the way in which we will create object-oriented programming. Using class, we can collect different data types or different variables into a single unit. That variable can also have methods associated with it. Method generally means function, but when we are using class, we usually say as methods, not function. So you can create a class by using the keyword class, followed by name of the class. For example, I am creating a class named dog and followed by a parenthesis, pair of parentheses. Okay, inside that class, I am now just using pass. Okay, what we did just now is that we created an empty class. This class is actually empty. It does not have any values associated to it. In order to create an object of this class, say object is equal to dog followed by parenthesis. Okay, now what we did is we have created a class named dog, which is actually empty. It passes. And we created an object from this class. Actually, when you create a class, it doesn't hold up any memory or it doesn't hold up any value. You can only start creating value once you create an object out of that class. You can check the type of that object, and we can see that now this object is a type of dog, which is a class. Now what we have done here is that we have created our own data type called as class, called as dog, which is a class. Okay. Now what if we wanted to store some values inside this class? So we need to define a method called init, which takes in an argument self. Okay. And you can assign self dot name equal to, let's say, Pluto. Okay. Now you can see that rather than having an empty class, I created a method for this class. What you are seeing here is actually called as a constructor. It is followed by two underscores, init, and again two underscores. So init is actually enclosed within two underscores. What this init function does is that whenever you create an object of this class, this is the first function that will be automatically executed. For example, in our previous case, when we go and type object dot and followed by tab, you won't see any recommendations or any functions. Now try running this cell, create an object, type, and when you type object dot, you can see a recommendation called name. See, now what did we just do now? What we did is that we created a class called dog, and now that dog has a variable called name. Okay, so whenever you created an object, you can, in order to create an object, you actually need to use the class name followed by a pair of parentheses. So when you call this, you actually creates a function, creates an object and giving it a name called as object. Okay, so this object has an, you can say, a data element called as name. So when you try like object dot name, you are actually seeing Pluto. This is what internally Python has also does for list. Okay, list dot. See, why are we seeing all these functions here? This is because list is actually a class which has defined functions like this. Okay, that is what we are doing here. So now comes the concept of self. Okay, in order to tell the class that this is actually a variable belonging to that class or a method belonging to the class, you need to make use of self keyword. Okay, so when you are creating that function, you have to specify self as an argument. So whenever you are creating a variable that is associated with that class, you need to explicitly use self dot followed by the name of the variable. Okay, I can create like lots of variable for this class. For example, I can create another variable telling age. The age of this dog is 3. Okay, self dot owner. The owner of this dog is Manu. So now when you create an object and call dot on it, or you can see that we can see 3 different variables that is associated with this class. Okay, so you can check the owner's name by calling object.owner. To be more clear, I will use a proper name. Yes, my dog. Okay. See, my dog's owner's name is Manu, and my dog's name is Pluto. You can use his age is 3. Like so, you can have a collection of variables bundled into a single name. You can also have your own functions defined inside this class. For example, you can have bark. To tell that this is a function of that class, you need to use self. I'm just printing it. Okay. Now, what we just did is we have created a function that is a method of this class dog. See, whenever we create an object now we will see that function here too. See, now we are seeing bark, which was actually a function. And when we try printing bark, we are actually getting that function. Why are we getting this? It is similar to all those functions. So in order to call a function, you need to make use of parentheses. That is how you call a function. And we can see the output as oof. Like creating this single function, you can actually go on and create your own different kinds of functions. Now let's look at another thing. What if all these values needs to be dynamic, or you need to pass it? Now we can see that whenever we create another object, let's say my dog 2. Okay. See, both my dog 1, my dog, okay, I will create my dog 1. Okay. Both these variable are having same values. Okay. My dog 1 dot name is also Pluto, and my dog 2's name is also Pluto. What if we have to change this behavior? What if we have to pass on dynamic value inside that class? So that is when you can pass other arguments while creating an object. So one more time, I'm repeating what is the use of this init. Init is a constructor object or constructor method which is used or which is called whenever that object of this class dog is created. So whenever you create an object of this class dog, this init is the first function that will be executed. So we can pass in here dog's name. Okay, like dog's age. Dogs, I'm just removing the owner for now so that it is easy. Okay. So when we run this, now what we can actually do is we can now okay, let me change this also. Okay. So what we are seeing here is that now we have created a class that takes in different arguments while the object is being created. So you can pass the name of the dog as Pluto. His age is 5. And the next second dog's name is Bruno, and his age is 2. Okay, so when we now create those object and see, now we are getting 2 different names. This is the use of a class. Using a single class creates an abstract for storing different values. For like in a real world example, let us look at the class of students. Okay. You are creating a project where you need to store details of student. So storing details of student in a single list is actually not a better approach. He may have different properties or methods to be implemented. So that is when we make use of class. You create a class name, students, and inside init you pass in self. Okay, and say that let's assume I am creating a student for a college X. Okay, all these students are of college X. So what I can do is I can create a college name of college that would be X. Okay, and he can have names associated, like his name, his age. Okay, now I'm using self dot. I'm passing his name as name. Self dot. I'm passing age. Age. Okay. Now what will happen if we create and like say for I just specified for creating or linking the object in we need to use self, right? So I have not used self here. Why? This is because this variable is actually outside of all functions and that is inside this class. So by default, Python identifies this is an object associated with the same class of students. The name of college will be now common for all the objects that is being created from the class students. Now let us go and create a student 1, S1. Okay, I'm saying name of student is Manu and his age is 25. Okay, I am creating another sequence. Your name of student is Rahul and his age is, this is like too much. Okay, okay. So now we just created two variable and when we press in tab we can see the college of that student, name of that student, and so on. What if you have to get his mark? Okay, you can define a function and say get mark, passing in self to say that this is actually a function of that class, and I'm just passing total mark. Okay, self dot mark is equal to total mark. Okay, so now what I did is I just created a class which has a method called getMark. So I can actually use that getMark. So now when we press tab, we actually don't see a variable called as mark. We are only having a variable for a method called getMark. And I am passing a mark of 100 out of, let's say it's out of 100. I'm giving him 80. Okay. Now once that is done, now when you type in, see, now you can actually see a new variable mark. This is because only when you call getMark, this class gets a new variable called as mark. So only when you call this getMark, you will get a new variable self.mark. This is because when an object was created, only this function was executed. So at that time, only two variables, that is name, age, and a method getMark was available. So once you call getMark, now you also have another variable called as dot mark, that is self dot mark. You can actually print in the mark. Okay. Srinivas is having a trouble. I tried to run object dot name, but it's throwing error. How to define constructor? Because whatever I mentioned in video is not working. I don't know why it is not working for you. Can you make sure that it is Python 3 itself? Just because it is working fine for me. Can you just copy paste the code that you have used, Srinivas, so that I can see the mistake that you have made? Okay. Now continuing. Now we have looked how to create, that is, we have looked at how to create a class and object. Now let us look at inheritance and polymorphism. Okay. There are, now what is inheritance? Inheritance is actually using one class or using the properties of one class to create a new class. That is called as inheritance. Using a base class, you can create a derived class that has the properties of base class. Okay, I will show you an example. I am creating a class called colors. I am using an init function. And I'm passing self dot okay. Now what I did is I created a base class called as colors. You can do this. You can create a new class called as blue, and use that class name here. This is how you actually do inheritance. While creating class, you can pass in the name of another class. This shows that the class blue is actually inherited from a class called as colors. Init self, and I am okay. Now I am going to create an object of this class blue. So when you type in object dot, you can actually see the color blue. But I just said that whenever you inherit a class, you should also get the methods or all the variables and methods of that class, right? So you should now get the color type here too. So why isn't that happening? This is because you actually need to call the constructor of base class when you are defining your derived class. This class is called as base class, parent class, or superclass. The class that inherits from a base class or parent class or superclass is called as a child class, a derived class, or a derived class. Okay, so color is actually a parent class and blue is actually a derived class. So whenever you are defining a derived class or whenever you are creating a derived class, you need to call the init of your parent class. Now I am going to say colors dot init, and I'm passing in self. Okay. Now when you run this, now you can see you will get that color type over here. Okay. This is how inheritance work. The class blue now actually contains the variable of its base class. You can also define, can I say, for a more example, I'm going to define another thing. I'm going to name this as vehicles, and let this be a car, and I'm going to create another thing, bike. Okay, from a base class I'm defining type equal to vehicle. Okay, so rather than that we can use anything. What can I use? Has wheels. Okay, and inside this what I am going to do is I'm going to say has paint. This car has, okay, number of wheels equal to 4. For bike, number of wheels equal to 2. See? Oh, sorry. I actually need to use vehicles here and here. Okay, that's done. Okay, now when you create a object, let's say I'm creating an object 1 which is of vehicle. Okay, you can check the type, that is vehicle, and that will only have has wheels equal to true, because that is just a base class. Okay, now we will create a object of the child class. Let's say now I'm going to create an object 2, that is class. Okay, so now when you check the type of object 2, you can see that okay, you can see that first object is actually a base class and second is actually a child class, and that child class will have both the properties of why am I saying color? Okay, I didn't run this cell. Okay, okay, color type. Where did that come from? Oh, sorry. Sorry. That is because we were actually calling colors here. Sorry, guys. Okay, let's run this. Now, when you press in tab, you can see that the child class already has the variable of its parent class, that is, has vehicle. See, and his that number of wheels of that object is 4. You can actually go and check is instance of is an instance of, let's say, car. Hmm, uh, I just forgot how to used to do. Okay, anyways, let me check on, guys. I just forgot to do that. Okay, leave it. So this is how you actually do inheritance. Okay, so there are different types of inheritance. What we just did is called a single inheritance. From a base class, we just created a derived class. Now there are other types of inheritance. From two base class, you can create a derived class. For that, what you actually need to do is, let's say I also have a class called color. I also have got a class called color h in it. Self has color equal to true. Okay, so how can we do this multiple inheritance? That is, the child is actually being created from two base class. For that, you can pass in vehicle, comma, color. Okay, which, so now when we go and create an object of you can actually see that object 2 has got, you need to call, since I have used color, I need to call the superclass of color 2. Okay, so when you do this, you can see that now this object has color. So this is how you do multiple inheritance. Now coming back, there are multi-level inheritance, which means that from a base class, you created a child class. Now that child class actually acts as a base class for the second child class. This is called as multiple inheritance. There is hierarchical inheritance, where from one class, you can actually create many child class. That is an example of students class that we just saw. From a student class, you can actually from a base class you can actually go and create different child class. That is uh, what a hierarchical inheritance means. So what is an hybrid inheritance? That is using any of the above mentioned, that is hierarchical inheritance, multiple inheritance, or multi-level inheritance, and coupling these will give you a hybrid inheritance. So these are the different types of inheritance. Now we will look at polymorphism. So what is polymorphism? It is actually you can make use of same name for different functions of different classes. Let's say I have a class called car. Okay, let us say use the same thing here. Okay, car and bike. Okay, I'm just ignoring this color for now. Okay, I'm creating two functions, cars and bike. Okay, see, now we can actually define a function called get name. I'm going to give a name for this car. Self my name self dot name. Okay, I just saw the comment from Srinivas. Srinivas, you did a mistake by using def underscore init. Okay, you have to do two underscores. That is underscore underscore init. Okay, underscore underscore init. Not okay. Not def underscore init. Okay. Okay, I am giving name as name and just passing the same thing over here. Okay. See, now when you use bike, both car and bike has same function or same method, even if they are of different class. So even if they are in different class, object 1 dot will have get name and object 2 dot get name. See, even if they are in different class, you can use same methods. That is the use of, that is the property called as polymorphism. Now you can actually override the method of parent class. I'm defining a parent class and self. One thing to note is that you can actually have a function without init method. Okay, so if there is a class, in a class you don't pass use init. For example, I am not going to use init here. So I'm just defining, let's say, print, or let's say display x. Okay, so this actually works. So this shows that you can actually create a parent class without an init. So parent class, I'm assigning that to an object P. So P is the object now. So P dot will have a method called displayX. Again, I'm displaying X. So this shows that you can have a class without an init. That is also possible. So the use of init is that whenever you create an object, if you want to have some variables assigned, then you make use of init. Now let's say I'm defining an init. Self dot name equal to, let's say, that. Okay. Now I am going to create a child class. Okay. Also on parent class. So inside init, I'm going to create self dot child name equal to y, and I am also going to call my parent class. Okay. Now what you can actually do is you can override. So now when we run this, and when you go and display C, you will see that it is displaying X, or this is a third of parent. Okay. So even if you have this, you will say this is a method of parent. You can actually override the same function. You can use the same name here. Since we are already inheriting, this display X will be already available here. So what I am going to do is I am going to override the same function. Override means change the existing thing and apply a new thing. So I am going to use the same thing here, display X, and now I am going, this is a method of child. Okay. So once that is done, now when you you will see this is a method of child. So that is how you can override a method of parent class. Now special methods. By looking at special methods, we will be winding up all the concepts about object-oriented programming. So what is special methods? Okay, I'm going to create a class student. It's in a name and an age. Okay, and I'm assigning that as the variables of this class. Okay, when you create S as an object, and you need to pass in the name. Okay, Manu Sage is to be two. Okay, that should create a class. Now, when you go and see S dot, and you should see name and age. Now, what if you go and try to change the type of this class and you say str of S? You will get something like this. You can change this default behavior. For example, in the case of like a number, mm, say list is equal to. Okay, I will show you how that is done. We'll go in here and create str, and I'm passing in self. Okay, once I have self here, I can use all the variables that is available inside this class. So I can go and say return or print. Name is self.name, age is self.age. Okay, CR of S. Okay, that is actually do is change. Okay. See, now when you did this, you actually got name is Manu and age is 22. This is actually called as a special function or dunder function. That is similar to the init. All the dunder function starts with two double underscores. Okay, there is another dunder function like length. Okay, I can return the age here. Okay, so when you go and do len, I'm creating a student, and when I go and see length, now I can see, oh sorry, self dot age. Okay, I can see 22. So length and str are dunder functions. You can use dunder functions if you have needs something to be displayed like this. So this is the use of special methods or dunder functions. So with that, we conclude on object-oriented programming. So you can ask questions now if you have any. Okay, Srinivas, this video will be always available. You can go through this video if you have missed out something. Srinivas just said that he has missed out something because of an issue. So you can always find this video and just go through it. Only 6 participants are watching now. Okay. I don't know why we are seeing a sudden drop in number of participants. You can ask questions if you have any. I will like wait for 10 to 15 minutes. If there is nothing, then I will just leave. The video is actually available in our playlist. That link has been shared in the WhatsApp group. You can see the WhatsApp group. So, do you have any other doubt? You can ask doubt if you have in the previous classes. If you had any doubt, you can just ask it now. Like functions and list data types. If you have any doubt in our previous class, you can ask it now. Actually, we have now covered the half of the topics. Next, you will be having a mini project and a meetup. So we can personally meet each other and share our like your goals, what you have to achieve. We can really help you out. So all those details will be mailed to you. So don't worry. Okay, guys. Since no one is having any doubt, I think I will leave. Okay. Thank you, guys. Thank you for attending today's session and have a good day. Bye. Bye, guys.